Casey, the Chief Technology Officer for Forum Systems. And today's webinar topic is the fundamentals of enterprise API security. The agenda today will be basically just a brief overview of Forum Systems that I will provide at the start, and then hand this over really to the core aspects of what today's webinar is comprised of, which is our guest speakers Nolan O'Dwyer and Randy Heffner. Nolan O'Dwyer is a distinguished HP enterprise architect for Hewlett-Packard and is a visionary in his field. Really, Forum Systems has had the distinct pleasure of working with Nolan and HP to deliver some high complex mission critical infrastructure to the UK government sector. And Nolan's truly an innovative leader in his field, and we're really pleased that he's offered to share his vision on architecture design principles for successful and secure deployments in cloud and software-defined networks. Also, we're joined today with Randy Heffner, the VP and Principal Analyst at Forrester Research. Forum Systems has been working with Randy and Forrester for many years through really the evolving landscape of technology, and with some specific focus on the areas around API enforcement and API security. And today, Randy will be discussing layered security and API architecture and bring his experience in field research to bear on this topic. So just a quick some quick overview and background from Forum Systems, who we are. We've been around for the better part of 14 years now, established back in 2001. Our core focus is on API security. We actually build a product technology called Forum Sentry. It's an API security gateway. It's a gateway that we've basically, through over a decade of innovation, have focused on really the area of security, but by delivering a technology platform that is a secure platform in and of itself, having achieved some industry security certifications that are really identify and uniquely frame our technology in the industry as a security technology first and foremost that delivers the enterprise value. And so really that's our focus, is API security. That's the combination of cyber security capabilities, authentication, data privacy, and data mediation, all fundamentally wrapped up into a product technology that delivers all of that and converges those functions into the capabilities around API enablement and information assurance. We have, as we'll showcase today, some good experience over many years. We're a provider of technology globally for governments and enterprises. And really the key that we focus on, and I think that will be identified in the conversations today, is focusing on future-proof standards-based technology. That's really our approach and has been since inception, is purpose-built, vendor-agnostic, standards-based technology that can unify networks, that can simplify architectures, but with the principles of security as a core aspect of those design principles and capabilities. And specifically, core focus today, we'll be talking about how that applies really in the cloud, virtual, and software-defined network world. A big part of the necessity to build those principles from the ground up. And so really what our focus is as a technology provider in the industry is around that agility aspect of security, that we effectively focus and consolidate various capabilities around mediation, identity, data security, privacy, trust, threat, access control, logical capabilities, and single sign-on to unify those capabilities in proven technology, purpose-built, in order to deliver this capability and these capabilities that are going to be discussed today around those principles of information assurance and API security, by having those capabilities be a part of the landscape of the architecture and facilitating those capabilities in technology design specifically for that intent. So that's really who we are as Forum Systems, that Forum Sentry product. That's without further ado, really want to now turn this over to to the next phase of the webinar and have Nolan share with you his vision and experience in this field. So Nolan, I'm going to go ahead and turn this over to you to go ahead and bring up your presentation.
Hi Jason, thank you for the glowing introduction. Let me just pull up the slide deck for you. Okay, Jason, can you see the deck?
Yes, it's up and visible.
Yeah. All right, thank you. Okay, as I say, thank you for the introduction, Jason. What I'm going to walk through today, it's not so much a HP strategy view, but really a personal point of view around where I see enterprise API gateways going, particularly in a cloud context. And this is not in any sort of great visionary sense, but more around these are practical things that we've had to do or consider as we've gone down a cloud journey and the security associated with the cloud journey. It's very much based upon immediate problems we were hitting in terms of providing a strong security stance, particularly as most of the work I do is in the European government space, where security is of paramount importance. Okay, so let's look at cloud. The dialogue for cloud all started off in the infrastructure space around cheaper commodity tin, in essence. However, that's really revolutionising more the application space now, where we're looking at the rise of the cloud native application, where we're looking at the drive for increased agility and increased speed of delivery. And this has changed the way we consider applications. Scale out, not scale up. Open source, not closed. Distributed, not monolithic style applications. And a key one for me, and one of the drivers around our engagement in the enterprise API gateway space, was the move towards API style integration versus the old enterprise service bus, monolithic, internal to the enterprise. By an API centric architecture, what I really mean is the idea of intelligent endpoints but dumb pipes, in essence. The idea being that you build an API on the application, and that API is consumed by another application, and the intelligence around, let's say, transformation and normalization is built into the application, rather than the older model where that might have been built into an ESB. So that gives a great deal of flexibility, a lot more power in the delivery capability, particularly when we look at the old SOA model, which was strict contracts and fewer known developers. Here we're looking at much looser contracts. In many cases, you could say it's a self-service architecture style. Integration patterns, not strictly what we're looking at here, it's almost pipe management. And it could be a huge number of developers rapidly increasing delivery velocity. Okay, so one buzz phrase I've heard a number of times: API architecture, new application architecture, and I can understand that in this sort of new API-centric world. But that in of itself brings its own challenges, particularly to my mind around security and the management of those APIs. I think this is where it brings to bear the case for an API gateway. From my perspective, an API gateway is a hardened appliance that focuses on security of the APIs exposed. It supports a number of open standard protocols, preferably so, JSON, AMQP, etc. It's responsible for routing, protocol conversion, policy enforcement, schema validation, etc. All the things which may not have been built into the calling API, but which we can impose through the gateway. I actually raised the question with Jason and his team some time back. Well, what is the future of the API gateways given the rise of next generation firewalls, where things are being amalgamated and collapsed? And I think the rise of the cloud has given the perfect answer back from Jason, in that if you look at a cloud platform, the security is primarily focused on the infrastructure. Here we're looking at securing the API, and by securing the API, we're securing the application. So I see a clear differentiation between what I'll call the infrastructure approach to security versus something that's much more closely aligned with the application deployed onto that infrastructure. API gateways, to my mind, are becoming more important given that close synergy with the applications and associated APIs being delivered, particularly with the rise of the microservice style architecture. So I see the API gateway is very much a key component in a cloud security model, a layered cloud security model. The slide is fairly busy, so do forgive me, but it's attempting to show where the various elements would sit in terms of one, the cloud provider, where I'd expect perimeter security to be provided as part of that standard, a level of network security provided, and platform security, though that is a movable feast depending on what type of platform as a service or infrastructure as a service you're actually purchasing from the cloud provider. And all those reporting to a cloud infrastructure security, event management type capability. And it's very much generic controls aimed at the infrastructure provision. But if we go up the stack, we're looking at data controls, application controls that sit very much with you as the business owner of that application and that data. And this is where I see the API gateway very closely aligned with the application element as discrete from the infrastructure security element, i.e. this is a control under the control of the business and reporting to a business SIAM type function. What crossover between the two, cloud and business, in terms of reporting capability is then dependent upon the particular cloud provider you're dealing with. But again, I think if we look at this layered model, we can see where the gateway adds real value here, not just at the loose integration contract level, but also around the encryption and validation of that data going through it. Okay, that all sounds great, but okay, if we want to deploy it into this sort of layered model, we came up with let's say call them 5 big rules in terms of what we want to see in the gateway and how we want to manage that API gateway. The first key one for me is that I can no longer afford to deploy hardware appliances. In fact, I can't if I'm going out there to a cloud provider in many cases. So I need to be a software appliance. It's got to be a cloud-ready delivery. I can drop on a hypervisor type technology. So discussions as to whether we're moving down to more container-based in the future and how we secure that. And also the association with that is I want to be able to move the workload. I might be deployed into Cloud 1 today. There's no guarantee I want to be in there tomorrow. I will, and we're seeing this more, shop around and move our workload around various cloud providers. I want it to be pattern-based. I don't want every single delivery to be hand-cranked. Pre-built patterns to increase delivery velocity. Let's take advantage of the applications and work we do and increase that velocity to get payback more quickly. The other big one for me is everything is code. I don't want to be configuring these things by a console any longer. I want it to be an integrated part of my delivery cycle where I can automate it, and I treat this as just another piece of code which I can push via an API onto the appliance. And the key one for me as well, this has to be lightweight. This is performing a set of lightweight API security and acceleration functions. From my perspective, I don't want this platform to do heavy lifting type functions such as choreography, orchestration, business data transformation, normalization. These should not be deployed onto API gateway function, in my opinion, but should be handed off to something optimized for that. And that may in effect be an ESB. I'm not saying this replaces an ESB. This can be very much complementary to an ESB, particularly if you're using an ESB, for example, internally in traditional hosting style, traditional application style. This provides a secure gateway into that ESB. I also think we need to rethink how we want to use these gateways. In my view, I want it to be declarative based. I don't want to be deploying code onto this platform. It's, in my view, should be a pre-hardened box I want to use proven out-of-the-box policies. I don't want to put code onto this box, which may impact my security stance. And that's been a very, very, very key element to the way we've approached some of the deliveries we've done to date. Okay, so now we talk about delivery. Let's look at the delivery vision around what we're trying to achieve. One of the big dilemmas I had when we set out on the API gateway journey was who actually supports, manages and deploys onto the gateway. Is it a security appliance? Is it networks? Is it apps? Where does it sit? I mean, it crosses across all of them in essence. At the same time we started out upon this journey, we had the rise of DevOps, the idea of this joint development and IT operations type approach, where we're breaking down the silos in many cases, one between the various disciplines within IT, and two, that sort of wall between development and operations, so it becomes a single team. The DevOps model actually suits the API gateway model extremely well because it breaks down the silos. It aligns really well with the DevOps operation where we have mixed skill, multi-skilled people sitting within the delivery team. So we're aligning, in my delivery terms, the API gateway as, in many senses, an application capability. We treat it as code, and this also then means I can use the DevOps style tooling as well as the DevOps team to actually deploy and manage to these gateways. Key things to consider: everything is code, no console API. Cross-discipline, we have network security, application skills within the team, and key is reduce delivery time by that enhanced automation and delivery orchestration to the gateway. And the big one back for me is monitor what you can on the gateway as well, not only from a security perspective, which is key as part of your wider security stance, but also in terms of improvements and continuous delivery onto the gateway. The idea that you've got a gateway set up there, you deliver a set of rules to once and leave it, I think is dead. What I'm looking at is continuous improvement and continuous integration and delivery onto that platform to, one, improve the security stance by extending the rule set, but also to improve the velocity and speed of transactions through that gateway as well. So from my perspective, I would strongly advocate a DevOps model for the management and delivery of the API gateway. So how does this lead us into a bigger picture? Okay, so let's think about it. We're moving into a world where the hybrid cloud is becoming a reality. And we're dealing with traditional hosting type clouds, traditional enterprise style hosting. You may be deploying a private cloud for higher value assets, public clouds, potentially multiple, depending on the type of workload you want to deliver, and moving up the stack. It's not just delivering software as a service or platform as a service, but also business processes as a service spread across multiple cloud providers. For my mind, this even strengthens more the case for the DevOps model aligned with an API gateway. The DevOps model allows us to deploy centralized automation and monitoring to multiple gateways deployed across multiple clouds. And it's worth adding that here in the diagram I'm showing these as boundary devices, edge devices. I would advocate using those same devices for the securing and managing of internal communications as well, such that you're securing not only the edge but also your internal capability as well. So service to service within the cloud, use the gateway again to secure that service. That sounds hideously complex, which is why centralized automation and monitoring. One of the side benefits of this is the no centralized hub reduces latency. Again, this supports a scale-out model in terms of, rather than everything running through a single monolithic ESB style, it's running through much smaller, lightweight gateways, reducing your latency, which has even become more of an issue across distributed networks. Couple of important things as well. This service abstraction i.e. abstracting the gateway away from a monolithic ESB and also ensuring that individual services talk to the local gateway and then the local gateway mediates out across the cloud. That makes it easier to move your workload around, where from your centralized DevOps capability, you can move the various rule sets between the gateways in the same way you'd move the applications, and also then it simply becomes an addressing and routing issue around it. So this gives a very flexible model for delivery across multiple clouds and support for hybrid cloud model. Okay, so I had a quick tiptoe through sort of like vision of where I'm seeing us moving towards with the API gateway, and we have delivered a number of implementations along these lines. And what I'd like to share is some part and thoughts around the sort of big ticket items we've gone through. So I'll run through these extremely quickly before I hand back to Jason and the team. Cloud brings a transformation in the way we deliver applications. It's changing, whether that's microservice, cloud native, or whatever. That means an API-centric architecture is becoming more prevalent. That brings in itself new challenges around security, compliance, and management. I strongly believe in the use of API gateways to support and secure the APIs, but from our perspective, that's only part of the story.
Yeah.
It's more than just the technology. You need to have a DevOps mindset in terms of how you want to manage and deliver these, and a nice strap line to finish with: automate everything and monitor as much as you can afford to support that delivery. Thank you.
Three on your list.
Thanks, Nolan. That was great, much appreciated. And I've forgotten at the outset to remind everybody participating that there is a questions panel that you should see on your GoToWebinar right-hand side. And so do feel free to pose and ask any questions within that panel. And at the conclusion of the webinar, we'll go through those and ask questions of Nolan and of Randy from Forrester. So do feel free to make use of that. So without further ado, I can now bring to you Randy Heffner, again, for those joining a bit late, the VP and Principal Analyst at Forrester Research, who is going to be discussing today the concepts and his experience in field research around layered security and architecture. So Randy, I'm going to go ahead and hand this over to you. Bring yours up.
Great, thanks, Jason. Let me get, since I can't talk and point my mouse at the same time, let me get my screen shared. There, we should be seeing my title slide now, and away we go. So what I want to talk about, how I want to go through this, my part of the session is to jump from Nolan's remarks up to a higher business level way of thinking about, well, what's going on in this sort of shift to the cloud and digital transformations and the like, and then drill from there down to a specific example we can work with, and this will be an Irish telco, and then, oops, sorry, there we go. Okay, sorry, my screen was talking to me for a moment. It distracted me. But anyhow, so down to a specific example. This will be an Irish telco, and then from there to take a brief look through how many considerations there are in this sort of layered API architecture, and then go into a bit of how cloud affects that and how to think about security across cloud boundaries, and then come back to the top of Nolan's pyramid diagram where there was application security and data security, and talk a bit from an example of data intersection with API security. So so that's the notion. Let's drill in and start from this business view. APIs change the way ecosystems operate, and you see a broad shift from tight and controlled to a more dynamic and secured environment. And there's some nuances in how we think about this, but since the beginning of SOA days, there've been SOA, external integration via SOA, typically among smaller sets of partners and smaller communities. But that was part of a model where we viewed enterprise security and our edge, to the outside world, the edge connection to the internet, as being a hardened boundary, and inside was much softer. So doing integration or SOA and APIs and that, you would often find people say, it's inside it's behind our firewall. We don't have to be as concerned about security. And so there was very much a focus on the edge and tightening security around the edge, softer security inside because it's trusted. Well, as we started doing more and more kinds of things over the internet, more kinds of business relationships and business integration points, and at the same time developing more flexible approaches to how APIs are used for mobile and kiosks and any other kind of external connection, then we wind up having to take a different attitude toward the edge, to where from a business point of view, we think of the edge being porous. We want to let lots of things in through the edge because we need to allow innovation through open APIs and dynamic supply chains and partner relationships, and consumers are getting in, employees are getting in. So we need to have lots of different kinds of connections, and so we think of it as being porous, but security is still there at the edge, but we think inside the attitude shifts to one of a zero trust kind of model inside. So rather than being trusted inside, and taking trusted security models where we authenticate or authorize only at the edge and then get inside and do whatever you want, we have to get more and more concerned about attacks at the edge, as well as letting lots of folks in. So security inside takes a zero trust approach, and here's where Nolan's point comes of a gateway being used not only at the edge but also inside, so that connections between applications, between edge interfaces and the applications inside need just as much security as at the edge. So we have a mindset of being porous, but security all the way through to allow a wide variety of ecosystem dynamics, whether it's Facebook and Twitter style open APIs, or B2B relationships, or employee apps, mobile apps, or mobile apps for consumers or partners, or so it's a different business mindset toward security at the edge and security inside. So it's one angle in the business view. When we talk about APIs, then there's another angle that comes up in terms of how we think about what we're targeting as a business, what our business strategies are related to APIs. And one way to understand this is to think in terms of four major categories of APIs. So I mentioned the Facebook and Twitter kind of thing, and this is often what gets the headlines in API conversations. I call these open web APIs, and it's where you're trying to open your business to be wide open to innovation from any sort of direction. Somebody who has an interesting idea of how to combine your business with somebody else's business and deliver some interesting value. A good example here from a public sector point of view is transport authorities like Chicago Transit Authority, Transport for London, who open APIs and allow public developers to create interesting ways to let the public access information about transit resources and schedules and the like. Well, what's happening there is that transit authorities are allowing innovation that they can't afford to do because they're on more constrained budgets. But where there really is a lot of more important activity going with APIs now is in a B2B space. So to drive deeper customized relationships in a B2B world than what can be done with standard EDI interfaces. EDI and the like still important, but you can do much more in a customized way, detailed process optimization, supply chain optimization, by connecting to partners and customers and suppliers in a B2B way. And we see actually more happening in this sort of API space. And then there are, of course, internal APIs, and sometimes people incorrectly associate internal with SOA and say, well, SOA is internal and the like. Well, no, SOA has been at the edge and external basically since we've been talking about SOA. But internal APIs serve a goal of creating core business flexibility on top of all of the enterprise applications that you have. And we'll talk a little more about B2B and internal APIs in the example that we have coming up of the Irish telco. And you'll see these often talked about in the industry as being public, partner, and private APIs. I prefer these terms because I think they're more descriptive of what you're trying to accomplish with the APIs. And the fourth one that I talk about that you don't hear talked about much in the industry is product APIs. And here, I mean whatever product or service that you provide and APIs into that to control it. And I'll just give a quick example here and then move on. But if I'm a hotel, then through one of the other three kinds of APIs, then maybe I let someone reserve a hotel room. Via a product API, I might allow someone to control the hotel room itself, parental controls on the TV, public, Wi-Fi settings for a business meeting that I have, or what have you. It can be a product, a service, physical product, software product. There's a whole interesting conversation there, but there are business strategies that tie to each one of these different kinds of APIs, and the different characteristics of the business strategy, what you're trying to accomplish with a particular business strategy, who the partners are, all of these factor into the kinds of security considerations and characteristics that you have to implement and put policies around for your APIs, and so hopefully the example coming up will help clarify a bit of how this happens. But across all these APIs, you need to have just a number of general threat mitigation measures that are important, and I'll just go quickly through these because I want to talk more about the authorization, authentication kinds of aspects of what's required for API security. But along with this trusted or zero trust kind of model, you assume attackers have gotten onto the inside, and that basically means you need security at each layer of the API. You consider all input to be evil. Basically, if you want to have hardened, strong, protected APIs, everything needs to be validated as it comes through an API at the edge, or how that API flows into other aspects of the layered implementations inside. Always encrypt, at least at the transport level. So validate links, structures, schemas, again, everything that you can. Whitelist what you can. If you're communicating with particular partners, maybe you want to whitelist the IP addresses or the specific domain names that requests are coming in from for extra security and allowing access only to those who are allowed. Secure coding discipline for the actual applications that implement APIs is a key bit, and auditing throughout. That's why I very much like the Nolan slide and with the pyramid and how every layer was feeding off to an integrated SEIM kind of infrastructure. So you can look in a detailed way through every aspect and layer of your implementation and find threat mitigation measures that are available and that should be implemented at each layer. But let's look at this Irish telco. So their situation was they had any number of core applications, big applications, been around for years, whether it's packaged or bespoke and the like. Well, on top of that, they had a number of integration technologies to deliver atomic services, on particular entities, on particular applications, and ESBs and adapters and orchestration and all that helped them to build the APIs that provided the business capabilities represented by multiple applications. So one API, one SOA business service might, in fact, in its implementation, need an ESB to coordinate access across multiple applications. When you're building applications new, then as Nolan was describing, you build them API first, and you build them to live within an API architecture. You still need some of these other technologies to adapt previously built things into an API-centric sort of world. But what these API business services as internal services allowed the telco to do is to build internal solutions for customer service and displaying bills and other things that could focus on the business capabilities provided by the business services and ignore the fact that there are all these core application siloed boundaries at the back end. Well, to control and provide the right perspective around these services, they have business policies that describe application authentication and authorization and some of these validation and threat mitigation measures that I was talking about. Well, this is great, provides good, strong business flexibility with these internal APIs for the telco. But the real story starts at this point where, given that business flexibility, they could take some of those same services and enter new markets and get new revenue streams off of those APIs. And a key example is a toll road firm that basically allowed their customers, folks driving on the road, to charge their toll charges to their telephone bill for convenience and for improved billing capabilities for the toll road firm. Well, it's the same services that are being exposed externally via same APIs, but with additional policies layered on top to authenticate partners, do security federation with the partner, to do rate limiting, to check for denial of service at the edge, to a number of other additional policies layered on top. And to complete the picture, though, what we should bring back another element that really enters at the internal API level is that there can be additional layered policy as those service requests make their way back to the back end for keeping security active, the trusted model, in those core applications. So still core application security there, keep the security models of those legacy applications in operation. Protect those core applications by rate limiting how heavy the load is put on those back-end core applications. So a number of different layers of policy that can exist. When you look across, sort of bring cloud into the picture, bring the diversity of infrastructure into the picture that is represented by some of what Nolan was saying, then you get what I call a multiple hybrid scenario. So your layered security has to think of a number of different kinds of factors where you may have a choice between one or the other, or you may have multiple things in operation at the same time. So, for example, you may have differences in where things are running. They're running in a data center, your own data center, which might be a traditional, physically managed data center, or up to a private cloud environment. You might have any number of different kinds of cloud-based resources that are part of your environment. So software as a service, platform as a service, infrastructure, integration platform as a service, whatever it might be. Across these different environments, there's a number of different elements to manage. Think of Nolan's pyramid diagram with data at the top and applications. but also there are different identities, integration flows, different ways of defining the network paths between things, and the organizations that are managing these different elements might be you as an API provider, or your partner may be managing identity. The service vendor or managed service provider might be involved in managing elements. What that means is there are brokering needs for brokering for identity, brokering for authentication, deciding who to trust. That brings a variety of security elements and requirements into the picture. We're talking about APIs and SOA as message flows, but there are many other kinds of connections that actually flow over messages as well. Events, publish, subscribe, data synchronization. Those flows may be inbound or outbound. Your governance around them may allow unlimited flows or metered flows of data. And then the style of security across any given connection could be operating at one or multiple levels: transport, message level, field level, encryption, security, masking. And then the last element that I'll bring out, which is not necessarily the last element that will differ and that you need to consider, but just to round out this picture, is an understanding of which identities are in play and which identities matter, and how do you understand and decide what that identity is authorized to do from an attribute perspective or from the context of when that request is coming through. And these flows happen across cloud boundaries. So think of, you've got a service consumer, whether they're on-premise or in a cloud environment, and they just want to call SOA or API interfaces basically across a virtual network. And here I'm using the term virtual network in a loose sense. It can be a tightly defined sense of a software-defined network and the like. But here what I mean is just, who knows, back to my previous slide, who knows where the actual endpoint is running. But the service consumer just wants to call an API and get a response and not worry about the virtual network, not worry about security considerations that the virtual network brings it to bear. So you may, for example, have something that is running on platform or infrastructure as a service cloud, and your API service interface manages security inbound to the cloud. You might have something where you have some on-premise applications, and maybe the call is actually not using a typical API protocol, but is using, as Nolan mentioned, AMQP or other messaging kinds of protocols or WebSockets or what have you. So you've got a messaging kind of security. Or you may have scenarios where you're calling into a SaaS cloud that somebody else controls identities and security on, and what you need is security outbound calling to that SaaS cloud. So different layers, different places where security comes in, different kinds of security. And so what I'm trying to paint here is a picture where you see that there are many different nuances, many things that if your application developers are trying to build all of these considerations into their applications, they're going to have a lot of work to do. It's going to be very complex work. And the thing is, they're going to get it wrong. It is much better to have these security concerns externalized from your applications. So the last angle that I want to take into the conversation today is to bring data ownership as a question into the conversation, and from there to paint a specific scenario in how data ownership can create different kinds of security federation and integration kinds of flows. And then we'll wrap with some recommendations. So different kinds of scenarios, and I categorize 5 major kinds of scenarios that data ownership affects API security. And they're, again, via my multiple hybrid slide, you know, if you think about that, there are going to be many different kinds of approaches and considerations, but I want to mention just the top kinds of considerations that typically go into API security. So if you're doing an open web partnering thing, so think Amazon Retail's product advertising API, you know, you as the API provider own the data, and you can basically say what's done with the data. Well, here maybe all you have is an API key and a digital signature or a two-way SSL kind of connection, or a single way SSL connection to secure the API calls, because you basically have control and you can say who can do what with the data. But if you're doing customer integration as the API provider, you want to let some third party access your customer's data. Well, your customers own the data. They're the ones who need to say that it's okay for this third party to access the data. That brings OAuth 2 into the picture, and we'll walk through that in a scenario here. But maybe it's a B2B process relationship. It's a supply chain optimization or something. So you own the data or your partners own the data, but it's owned within the context of a partnered business relationship. Well, you may need to here have some federated identity via SAML or an OpenID Connect to ensure that you know who the partner is. You may need to have federated identity so that you know who the employee at your partner is. But in any case, the trust is between you and your partner. And the example I want to run through is on the next slide is what I call a B2B service provider scenario, where I'm an API provider, but it's my partner's customers or it's their stakeholders that own the data. So think maybe I'm an HR benefits provider or an investment account holder or something, and I have a partner and they're an employer and it's their employees who own the data. Well, and that may keep federated identity in the scenario because we've got the partner thing going on, but it brings OAuth 2 into the scenario as well for authorization by the actual owner of the data. If you got internal APIs, you got a wide latitude, and there's a lot of enterprises who have SOA security as a strong foundation for that. But enough said on internal APIs because of the wide latitude that you have. So let's walk through this last scenario that I want to describe. So your service provider, again, think human resources benefits, investment accounts. You have a customer who is an employer, and it's the employer's employees who own the data. That's the scenario we want to talk about. So the employer wants to provide a mobile application where who is the resource owner, the data owner in this scenario, can get their data that is at the service provider, but they're getting it through an integrated mobile app that the employer is providing. So the employer maybe is providing a benefits mobile app that has multiple things that it provides, some employer functions, but some service provider functions as well. So that's great. In order to do this mobile app, we need API access into the service provider's application. And the issue that comes up is it's the employer, not the service provider, who knows who the employee is and manages the identity of the employees. That creates now some layered, brokered, federated identity issues that we have to handle. That brings OAuth 2 into the picture. So let's walk through this scenario and how this would work then. The employee wants to sign up to use the mobile app. They start with an employer's page, web page or whatever, to sign up for using the app. And that kicks off the OAuth 2 dance where the mobile backend now launches to redirects the employee to the service provider's login page, because it's a service provider who has to say it's okay to get into the API, but the service provider has to get the employee's permission. So the employee logs into the service provider's application, but remember, it's the employer who knows the identity. So the service provider now has to do a SAML dance with the employer to say, is this employee really this employee? So the full authentication scenario has to go back to the employer via SAML. So we've got OAuth 2 and SAML in the picture. Everything's fine. So the service provider allows the employer's mobile backend to get an access token, which is used then to authorize API requests. So great. What have we done so far? We've allowed the employer to have control over identities, the service provider to have control over access to the service provider's API, and trust between the three legs, the employee, the service provider, the employer, ensures that the employee says it's okay for the employer to go get the data. But let's push it one further. Maybe this service provider application wants to access something from the human resources application at the employer, so we may bring SAML validation back into the picture for that reason. So that's one example. Your examples may differ, but what I want you to take away from that example is that that there's a depth of layered security concerns, and that you don't want to try to build all those into your applications. More broadly, APIs should trigger an application security architecture refresh for your environment as a whole. They push the envelope on new business models and practices and the diversity of implementation concerns. And layered security has to be your default model. Zero trust, security for API calls at the edge, security behind those API calls, multiple layers on multiple dimensions. And then externalize security from your API implementations. APIs should be they should be implementing business logic only. I mean, what's behind the API interface. Sometimes there are some very intricate business rules for security that have to be within an API, very detailed authorization kinds of matching with accounts and this sort of thing. But aside from that, anything else should be at at an externalized level from the actual API implementations. So layered security, you've got to have it for your APIs. Jason, back to you.
Thank you, Randy. Much appreciated. That was great. To wrap up for attendees, I'll remind everybody again that there is a questions panel that you can pose any questions to, basically the topics that were discussed today. We do have a few questions that have come in, so we can go through those. Some of these were asked earlier on and may have been answered by some presentation materials, but let's go ahead and go through them. One of the questions that came up fairly early on was how to address last mile security. And I think the two areas where we've seen Nolan's presentation, the Nolan pyramid that we saw with the layered approach and the concepts of separation of application and data, and really the principles around API enablement to access applications and services, and as Randy has also discussed around layer security and zero trust, is you don't let the applications speak directly to each other, and you rather have the principled approach of information assurance and accessibility through those API layers of capabilities, so that your end mile or last mile applications and services are protected by those principles, by that architecture design inherently. And that's really a principle of and a primary concept of what was discussed today. The other question was how to secure APIs hosted on AWS. I think this, and I can certainly let Randy and Nolan chime in on this, but where we see this really, and I think was highlighted by Nolan in his view and approach toward architecture principles, is the separation of and disassociation of your data plane from your control plane by way of principled architecture that is mutable, agile, and not tied and bound necessarily to the virtual environment or physical environment by which it runs. And so those principles by design can lend to the ability to secure that API architecture regardless of where you host it. In fact, I think one of the key concepts around SDN and cloud principles is to try to design things under the context that you want to be able to be more agile about where it runs and versatile about the environment without having necessarily to be tied to that. Nolan, would you add anything to that around security for APIs hosted in sort of public virtual environments?
Yeah, I think you've said it all, Jason, to be honest. I think the real use case, frankly, for the API gateway is exactly that. It allows you to give much more granular control and security to your application independent of the actual cloud platform you deploy to. It's that flexibility and that alignment with the application and being application focused that I think is key. I think the AWS is a great example. There you're talking about commodity hosting, but that comes at a price in that you don't get tailored security for your application. And frankly, nor should you with the price point you're getting. That's something you have to build and deploy yourself.
Yeah, and I would just add in that even if you did something within the Amazon environment to secure those APIs, that winds up being a single endpoint kind of security model based on what you can do there versus the fact that the question expands from how do you secure something in Amazon to how do you secure all of the things that are running everywhere, since you don't have everything running in Amazon.
Absolutely. Another question that was directed to you, Randy, is around some of your last topics in the slides around authentication, and the question was, it's posed as how secure is a man-in-the-middle attack, and I think that was meant to be framed as, is there any concern in that paradigm around man-in-the-middle attack?
There certainly is. You risk, things that can happen from the standpoint of either direction. Somebody stealing tokens from an unencrypted connection, which is why one of the bits of advice was always secure, always encrypt at least the transport level, and it's one of the reasons why I wanted to go through all of the details on that multiple hybrids slide, even though that was just a lot of text to throw at you on one slide. What I'm trying to get across is the depth of analysis that you need to do to make sure that you're understanding where what are the virtual network paths that are involved. What is the starting point? One way, one of the risks of for example, web applications that gives rise to a man-in-the-middle attack is often consumer, somebody accessing a website, doesn't start with an HTTPS connection. They start with an HTTP connection that then is upgraded to an HTTPS connection, and it's in that transition that some man-in-the-middle attacks are propagated. Where they're initiated. Particularly if you get somebody who's sitting at a Starbucks or a Costa Coffee or whatever it might be, and using their public Wi-Fi, then often that's where somebody may be sitting and listening on the network. So yes, there's a concern. You do need to think through it carefully. It's a solvable problem, particularly when you think of API security as being outside the actual API implementation versus something that's embedded into it.
Absolutely, and I think you also called out some other of the concepts therein around OAuth 2 and SAML, which have capabilities and best practices leveraging three-legged OAuth and leveraging SAMLs with signatures for higher trust, which which definitely reduces the exposure or the potential of man in the middle through those principles of leveraging those standards for delegated authentication.
Right. Yeah. And what you're trying to do with these kind of approaches is raise the bar on how intrusive someone must be in order to get the credentials that allow them to do any improper impersonation of one of the security principles.
Excellent. So I believe that actually concludes the questions that were raised, and so I just want to thank our presenters today, Nolan and Randy. Thank you very much. This was a great overview and great detail and a very critical part and aspect of API architecture design and really the future of innovation around the industry. Thank you, attendees. As a reminder, any follow-on questions or information, certainly feel free to pose, and we'll